Okay, let's see one more important and easy question. Express train is moving at a speed of 30 meter per second, reducing its speed to 10 meter per second in a distance of 200 meters. 200 meters means it's reduces speed 30 meter per second to 10 meter per second in a distance of 200 meters. Generally, we are observing when the train approaches the station, they are reducing the speed by the application of the brakes. Yes, so they are reducing the speed by the application of the brakes. So depending on the distance, they are applied the brakes. If the distance is less, they need to use more force too. So because we need to stop it immediately. So if distance is more, they are applying less. So like they reduced 30 to 10 meter per second after traveling of a 200 meter distance. But they found that after that the station is approaches. So that's why they are increasing the braking force increased by 12.5%. How much percent? 12.5%. In the beginning means what is the beginning value? Here what is the value? That value is increased by 12.5%. Find the distance that it travels before comes to rest. So how much distance it travels before coming to rest? That is the question to us. So very simple if you catch the logic. Yes, first of all you can try to get what is the initial acceleration. Right? Initial acceleration is before increasing. What is the acceleration? See, is it possible to find or not? Yes, of course. See here. So I'll take okay, much space we have. We'll use this. So initial velocity is 30 meter per second, and final velocity 10 meter per second, and the distance of travel is 240 meters. Sorry, 200 meters. 200 meters. So now we need to get acceleration. Then A is equal to, not acceleration, actually it is retardation. V square minus U square by 2S. V square 100, sorry 10 square 100 minus 30 square 900 by 2 into 200 means this value you are getting around 800 by 400 minus 800 by 400 means the retardation is minus 2 meter per second square. Retardation is minus 2 meter per second squared. So this is common, easy only. But from here is the question. What they mentioned, now the force is increased by, means they are applying the force, means retardation is increased by 25%, sorry 12.5%. Percent, how to we can take? Initial how much? 2%. In 1%, in 2 means actually 2 meter per second. 2 meter per second, how much they are taking? Is percentage of acceleration. Take 2, how much it is taking? 12.5 by 100 if you are taking, means so it is coming 12.5 means 25 means 1 by 4 means the value is 1 by 4 value 1 by 4 meter per second square is increases. How much it is increases? 1 by 4% is increases. Then now what is the acceleration? Now what is the acceleration? Initial acceleration A1 and increasing acceleration is delta A. Increasing acceleration is delta A. Are you getting this point? See here. How much acceleration is increased? How much it is increased? By 12.5%. 12.5%. 12.5%. 12.5 means 1 by 8. 1 by 8. In 100, 1 by 8%. 1 by 8 means 2 by 8. Think about 1 by 4. 1 by 4. Try to get it. Try to get this point. In 2, 12.5% is how much? In 1, 12.5 into 12.5 means 12.5 plus 12.5, 0.25. 0.25, what we can able to write? 1 by 4. That's all. In case same question if they ask it, if it is decreased by 12.5%, decreased by 12.5%, here we have to take negative. If the same question if they asking, it is increased by 25%, so then you have to take 25% increases. So now what is the acceleration? Now the acceleration is 2 plus 1 by 4. 2 is initial, increased is 1 by 4. The value is goes to 8 plus 1, 9 by 4. 9 by 4 means 2.25. How much? 2.25. After increases, after how much percent? 12.5. 12.5 per 1. 2 is 12.5 plus 12.5. 2.5. Total 2.25 meter per second square. Increasing acceleration. Total acceleration. Now how much distance which travel before coming to rest? So see here, 30 meter per second to 10 meter per second, its acceleration is means 30 meter per second to 10 meter per second speed reduces, its acceleration is 2 meter per second. And 10 meter per second to 0 meter per second, its acceleration is 2.25 meter per second. Right? Here 2 meter per second square, here 2.25. Means here you need to find how much distance it travels. This is already you know that 200. Here how much distance it travels. That. So that distance S2 is equal to, again, final velocity minus initial velocity upon 2a. How much it is? V square minus u square by 2a. So v square 0 minus 10, 110 square by 2 into 12.25 means nothing but 5. So how much it travels? Next distance. Distance never becomes negative. Here it is retardation. So then how much further distance which travel? 20 meters. 20 meters before coming to rest.